Refrigerator.
A refrigerator is a common household appliance that consists of a thermally insulated compartment and a heat pump that transfers heat from the inside of the fridge to its external environment so that the inside of the fridge is cooled to a temperature below the ambient temperature of the room. Refrigeration is an essential food storage technique in developed countries. Lower temperatures in a confined volume lowers the reproduction rate of bacteria, so the refrigerator reduces the rate of spoilage. A refrigerator maintains a temperature a few degrees above the freezing point of water. Optimum temperature range for perishable food storage is 3 to 5 degC, 37 to 41 degF. A similar device that maintains a temperature below the freezing point of water is called a freezer. The refrigerator replaced the icebox, which was a common household appliance for almost a century and a half prior. For this reason, a refrigerator is sometimes referred to as an icebox in American usage.
History. Refrigeration technology.
Before the invention of the refrigerator, ice houses were used to provide cool storage for most of the year. Placed near freshwater lakes or packed with snow and ice during the winter, they were once very common. Natural means are still used to cool foods today. On mountainsides, runoff from melting snow is a convenient way to cool drinks, and during the winter one can keep milk fresh much longer just by keeping it outdoors. The word refrigeratory was used as early at least as the 17th century. The history of artificial refrigeration began when Scottish professor William Cullen designed a small refrigerating machine in 1755. Cullen used a pump to create a partial vacuum over a container of diethyl ether, which then boiled, absorbing heat from the surrounding air. The experiment even created a small amount of ice, but had no practical application at that time. In 1805, American inventor Oliver Evans described a closed vapor compression refrigeration cycle for the production of ice by ether under vacuum. In 1820, the British scientist Michael Faraday liquefied ammonia and other gases by using high pressures and low temperatures, and in 1834, an American expatriate to Great Britain, Jacob Perkins, built the first working vapor compression refrigeration system in the world. It was a closed-cycle device that could operate continuously. A similar attempt was made in 1842, by American physician, John Gorrie, who built a working prototype, but it was a commercial failure. American engineer Alexander Twining took out a British patent in 1850 for a vapor compression system that used ether. The first practical vapor compression refrigeration system was built by James Harrison, a British journalist who had emigrated to Australia. His 1856 patent was for a vapor compression system using ether, alcohol or ammonia. He built a mechanical ice-making machine in 1851 on the banks of the Barwon River at Rocky Point in Geelong, Victoria, and his first commercial ice-making machine followed in 1854. Harrison also introduced commercial vapor compression refrigeration to breweries and meat packing houses, and by 1861, a dozen of his systems were in operation. The first gas absorption refrigeration system using gaseous ammonia dissolved in water, referred to as aqua ammonia, was developed by Ferdinand Carr of France in 1859 and patented in 1860. Carl von Linde, an engineering professor at the Technological University Munich in Germany, patented an improved method of liquefying gases in 1876. His new process made possible the use of gases such as ammonia, sulfur dioxide, SO2, and methyl chloride, CH3Cl, as refrigerants, and they were widely used for that purpose until the late 1920s.
Domestic refrigerator.
In 1913, refrigerators for home and domestic use were invented by Frederick W. Wolfe of Fort Wayne, Indiana, with models consisting of a unit that was mounted on top of an ice box. In 1914, engineer Nathaniel B. Wales of Detroit, Michigan, introduced an idea for a practical electric refrigeration unit, which later became the basis for the Kelvinator. A self-contained refrigerator, with a compressor on the bottom of the cabinet, was invented by Alfred Mellows in 1916. Mellows produced this refrigerator commercially but was bought out by William C. Durant in 1918, who started the Frigidaire company to mass-produce refrigerators. In 1918, Kelvinator Company introduced the first refrigerator with any type of automatic control. The absorption refrigerator was invented by Båtsö von Platen and Carl Munters from Sweden in 1922, while they were still students at the Royal Institute of Technology in Stockholm. It became a worldwide success and was commercialized by Electrolux. Other pioneers included Charles Tellier, David Boyle, and Raoul Pictet. Carl von Linde was the first to patent and make a practical and compact refrigerator. These home units usually required the installation of the mechanical parts, motor and compressor, in the basement or an adjacent room while the cold box was located in the kitchen. There was a 1922 model that consisted of a wooden cold box, water-cooled compressor, an ice cube tray and a 9 cubic foot, 0.25 m3, compartment, and cost $714. A 1922 Model T Ford cost about $450. By 1923, Kelvinator held 80% of the market for electric refrigerators. Also in 1923 Frigidaire introduced the first self-contained unit. About this same time porcelain-covered metal cabinets began to appear. Ice cube trays were introduced more and more during the 1920s. Up to this time freezing was not an auxiliary function of the modern refrigerator. The first refrigerator to see widespread use was the General Electric monitor-top refrigerator introduced in 1927, so called because of its resemblance to the gun turret on the ironclad warship USS Monitor of the 1860s. The compressor assembly, which emitted a great deal of heat, was placed above the cabinet, and enclosed by a decorative ring. Over 1 million units were produced. As the refrigerating medium, these refrigerators used either sulfur dioxide, which is corrosive to the eyes and may cause loss of vision, painful skin burns and lesions, or methyl formate, which is highly flammable, harmful to the eyes, and toxic if inhaled or ingested. Many of these units are still functional today. These cooling systems cannot legally be recharged with the hazardous original refrigerants if they leak or break down. The introduction of Freon in the 1920s expanded the refrigerator market during the 1930s and provided a safer, low-toxicity alternative to previously used refrigerants. Separate freezers became common during the 1940s, the popular term at the time for the unit was a deep freeze. These devices, or appliances, did not go into mass production for use in the home until after World War II. The 1950s and 1960s saw technical advances like automatic defrosting and automatic ice making. More efficient refrigerators were developed in the 1970s and 1980s, even though environmental issues led to the banning of very effective, Freon, refrigerants. Early refrigerator models, from 1916, had a cold compartment for ice cube trays. From the late 1920s fresh vegetables were successfully processed through freezing by the Posthume Company, the forerunner of General Foods, which had acquired the technology when it bought the rights to Clarence Birds's successful fresh freezing methods. The first successful application of frozen foods occurred when General Foods heiress Marjorie Merriweather Post, then wife of Joseph E. Davis, United States ambassador to the Soviet Union, deployed commercial-grade freezers in Spiso House, the U.S. Embassy in Moscow, in advance of the Davis arrival. Post, fearful of the USSR's food processing safety standards, fully stocked the freezers with products from General Foods' Birds unit. The frozen food stores allowed the Davis to entertain lavishly and serve fresh frozen foods that would otherwise be out of season. Upon returning from Moscow, Post, who resumed her maiden name after divorcing Davis, directed General Foods to market frozen product to upscale restaurants. Home freezers as separate compartments, larger than necessary just for ice cubes, or as separate units, were introduced in the United States in 1940. Frozen foods, previously a luxury item, became commonplace.
Freezer.
Freezer units are used in households and in industry and commerce. Food stored at or below 18 DEGC, 0 DEGF, is safe indefinitely. Most household freezers maintain temperatures from 23 to 18 DEGC, 9 to 0 DEGF, although some freezer-only units can achieve 34 DEGC, 29 DEGF, and lower. Refrigerators generally do not achieve lower than 23 DEGC, 9 DEGF, since the same coolant loop serves both compartments. Lowering the freezer compartment temperature excessively causes difficulties in maintaining above freezing temperature in the refrigerator compartment. Domestic freezers can be included as a separate compartment in a refrigerator, or can be a separate appliance. Domestic freezers are generally upright units resembling refrigerators or chests, upright units laid on their backs. Many modern upright freezers come with an ice dispenser built into their door. Some upscale models include thermostat displays and controls, and flat-screen televisions have even been incorporated.
Commercial and domestic refrigerators.
Commercial refrigerator and freezer units, which go by many other names, were in use for almost 40 years prior to the common home models. They used gas systems such as ammonia, R717, or sulfur dioxide, R764, which occasionally leaked, making them unsafe for home use. Practical household refrigerators were introduced in 1915 and gained wider acceptance in the United States in the 1930s as prices fell and non-toxic, non-flammable synthetic refrigerants such as Freon 12, R12, were introduced. However, R12 damaged the ozone layer, causing governments to issue a ban on its use in new refrigerators and air conditioning systems in 1994. The less harmful replacement for R12, R134, tetrafluoroethane, has been in common use since 1990, but R12 is still found in many old systems today. A common commercial refrigerator is the glass-fronted beverage cooler. These type of appliances are typically designed for specific reload conditions, meaning that they generally have a larger cooling system. This ensures that they are able to cope with large throughput of drinks. As a result, it is common for these types of commercial refrigerators to have energy consumption of greater than 4 kWh a day.
Medical and scientific refrigerators.
Typically, medical refrigerator can be set at 40 DEGF to maintain temperatures in the range 2 to 8 DEGC, 35 to 46 DEGF. If frozen, then some products are to be discarded.
Styles of refrigerators.
Most households use the freezer on top and refrigerator on bottom style, which has been the basic style since the 1940s. Traditional style, also known as top-mount fridge, 1940s to present. Freezer top, refrigerator bottom. Although most of the earlier models, some of the cheaper later models, and still some mini fridges use the freezer chest, or what is known as the freezer in the fridge. A separate freezer compartment, not located within the larger refrigerator compartment, became the industry standard during the early to mid-1960s. Side-by-side style, also known as American-style fridge, introduced by Amana in 1949 but not popular until 1965 present. Left side is freezer and the right is refrigerator. Top refrigerator, bottom freezer style, also known as bottom-mount fridge, mid-1950s to present. French door style, late 1990s present. 2 French doors for refrigerator and bottom freezer, 4-door French door style, mid-2000s present. 2 French doors for refrigerator and bottom freezer plus an extra door above the freezer which can function as a refrigerator or freezer. Door and drawer, similar in concept to drawer-style ovens, whereby the entire contents of the freezer are pulled out on gliders. 4-door style 2013 present. 4-door style fridge with a French door refrigerator section and a lower section divided into a freezer on the left and an area that can be converted between fridge and freezer space on the lower right. In the early 1950s most refrigerators were white, but from the mid-1950s through present day designers and manufacturers put color onto refrigerators. In the late 1950s early 1960s, pastel colors like turquoise and pink became popular. Brushed chrome plating, similar to stainless finish, was available on some models from different brands. In the late 1960s and throughout the 1970s, earth-toned colors were popular, including harvest gold, avocado green and almond. In the 1980s, black became fashionable. In the late 1990s stainless steel came into vogue, and in 2009, one manufacturer introduced multi-color designs. Most home refrigerators weigh between 200 pounds, 91 kilograms, and 450 pounds, 200 kilograms, with some models weighing up to 875 pounds, 397 kilograms.
General technical explanation.
A vapor compression cycle is used in most household refrigerators, refrigerator freezers and freezers. In this cycle, a circulating refrigerant such as a 134 enters a compressor as low-pressure vapor at or slightly above the temperature of the refrigerator interior. The vapor is compressed and exits the compressor as high-pressure superheated vapor. The superheated vapor travels under pressure through coils or tubes that make up the condenser. The coils or tubes are passively cooled by exposure to air in the room. The condenser cools the vapor, which liquefies. As the refrigerant leaves the condenser, it is still under pressure but is now only slightly above room temperature. This liquid refrigerant is forced through a metering or throttling device, also known as an expansion valve, essentially a pinhole-sized constriction in the tubing, to an area of much lower pressure. The sudden decrease in pressure results in explosive-like flash evaporation of a portion, typically about half, of the liquid. The latent heat absorbed by this flash evaporation is drawn mostly from adjacent still liquid refrigerant, a phenomenon known as auto-refrigeration. This cold and partially vaporized refrigerant continues through the coils or tubes of the evaporator unit. A fan blows air from the refrigerator or freezer compartment, box air across these coils or tubes and the refrigerant completely vaporizes, drawing further latent heat from the box air. This cooled air is returned to the refrigerator or freezer compartment, and so keeps the box air cold. Note that the cool air in the refrigerator or freezer is still warmer than the refrigerant in the evaporator. Refrigerant leaves the evaporator, now fully vaporized and slightly heated, and returns to the compressor inlet to continue the cycle. Domestic refrigerators are extremely reliable because the moving parts and fluids are sealed from the atmosphere for life, with no possibility of leakage or contamination. In comparison, mechanically driven refrigeration compressors, such as those in automobile air conditioning, inevitably leak fluid and lubricant past the shaft seals. This leads to a requirement for periodic recharging and, if ignored, possible compressor failure. An absorption refrigerator works differently from a compressor refrigerator, using a source of heat, such as combustion of liquefied petroleum gas, solar thermal energy or an electric heating element. These heat sources are much quieter than the compressor motor in a typical refrigerator. A fan or pump might be the only mechanical moving parts. Reliance on convection is considered impractical. The Peltier effect uses electricity to pump heat directly. Refrigerators employing this system are sometimes used for camping, or in situations where noise is not acceptable. They can be totally silent, if a fan for air circulation is not fitted, but are less energy efficient than other methods. Other uses of an absorption refrigerator, or chiller include large systems used in office buildings or complexes such as hospitals and universities. These large systems are used to chill a brine solution that is circulated through the building. Many modern refrigerator freezers have the freezer on top and the refrigerator on the bottom. Most refrigerator freezers, except for manual defrost models or cheaper units, use what appears to be two thermostats. Only the refrigerator compartment is properly temperature controlled. When the refrigerator gets too warm, the thermostat starts the cooling process and a fan circulates the air around the freezer. During this time, the refrigerator also gets colder. The freezer control knob only controls the amount of air that flows into the refrigerator via a damper system. Changing the refrigerator temperature will inadvertently change the freezer temperature in the opposite direction. Changing the freezer temperature will have no effect on the refrigerator temperature. The freezer control may also be adjusted to compensate for any refrigerator adjustment. This means the refrigerator may become too warm. However, because only enough air is diverted to the refrigerator compartment, the freezer usually reacquires the set temperature quickly, unless the door is opened. When a door is open either in the refrigerator or the freezer, the fan in some units stops immediately to prevent excessive frost buildup on the freezer's evaporator coil, because this coil is cooling two areas. When the freezer reaches temperature, the unit cycles off, no matter what the refrigerator temperature is. Some people recommend setting the refrigerator to maximum and the freezer to a point where the refrigerated food will not freeze. Modern computerized refrigerators do not use the damper system. The computer manages fan speed for both compartments, although air is still blown from the freezer. A few manufacturers, such as Sub-Zero and Sunfrost, offer dual compressor models. These models have separate freezer and refrigerator compartments that operate independently of each other, sometimes mounted within a single cabinet. Each has its own separate compressor, condenser and evaporator coils, insulation, thermostat, and door. Typically, the compressors and condenser coils are mounted at the top of the cabinet, with a single fan to cool them both. This design, where no air passes between the two compartments, provides for more appropriate humidity levels and much tighter temperature control in each compartment. It also requires much less energy to operate, since each compressor and coolant system can be optimized for a specific temperature range. Further, opening the door of one compartment does not affect the temperature of the air or humidity level in the other compartment. Thus, it avoids many of the disadvantages of the much more common single compressor designs described above, although at a higher initial cost. Manufacturers of such designs argue that the increased cost is compensated over time due to reduced energy use and less food waste due to reduced spoilage. Alternatives to the vapor compression cycle not in current use include acoustic cooling, air cycle, magnetic cooling, Malone engine, pulse tube, Stirling cycle, thermoelectric cooling and thermionic cooling, vortex tube, water cycle systems.
Features.
Newer refrigerators may include automatic defrosting, a power failure warning that alerts the user by flashing a temperature display. It may display the maximum temperature reached during the power failure, and whether frozen food has defrosted or may contain harmful bacteria. Chilled water and ice from a dispenser in the door. Water and ice dispensing became available in the 1970s. In some refrigerators, the process of making ice is built in so the user doesn't have to manually use ice trays. Some refrigerators have water chillers and water filtration systems, cabinet rollers that lets the refrigerator roll out for easier cleaning, adjustable shelves and trays, a status indicator that notifies when it is time to change the water filter, an indoor ice caddy, which relocates the ice maker storage to the freezer door and saves approximately 60 liters, 2 cubic feet, of usable freezer space. It is also removable, and helps to prevent ice maker clogging, a cooling zone in the refrigerator door shelves. Air from the freezer section is diverted to the refrigerator door, to cool milk or juice stored in the door shelf. A drop-down door built into the refrigerator main door, giving easy access to frequently used items such as milk, thus saving energy by not having to open the main door. A fast freeze function to rapidly cool foods by running the compressor for a predetermined amount of time and thus temporarily lowering the freezer temperature below normal operating levels. It is recommended to use this feature several hours before adding more than 1 kilogram of unfrozen food to the freezer. For freezers without this feature, lowering the temperature setting to the coldest will have the same effect. Early freezer units accumulated ice crystals around the freezing units. This was a result of humidity introduced in the units when the doors to the freezer were opened, condensing on the cold parts, then freezing. This frost buildup required periodic thawing, defrosting of the units to maintain their efficiency. Manual defrost, referred to as cyclic, units are still available. Advances in automatic defrosting eliminating the thawing task were introduced in the 1950s, but are not universal, due to energy performance and cost. These units used a counter that only defrosted the freezer compartment, freezer chest, when a specific number of door openings had been made. The units were just a small timer combined with an electrical heater wire that heated the freezer's walls for a short amount of time to remove all traces of frosting. Also, early units featured freezer compartments located within a larger refrigerator, and accessed by opening the refrigerator door, and then the smaller internal freezer door. Units featuring an entirely separate freezer compartment were introduced in the early 1960s, becoming the industry standard by the middle of that decade. These older freezer compartments were the main cooling body of the refrigerator, and only maintained a temperature of around 6 degC, 21 degF, which is suitable for keeping food for a week. Later advances included automatic ice units and self-compartmentalized freezing units. An increasingly important environmental concern is the disposal of old refrigerators, initially because Freon coolant damages the ozone layer, but as older generation refrigerators wear out, the destruction of CFC-bearing insulation also causes concern. Modern refrigerators usually use a refrigerant called HFC 134, 1,1,1,2-tetrafluoroethane, which does not deplete the ozone layer, instead of Freon. A134A is now becoming very uncommon in Europe. Newer refrigerants are being used instead. The main refrigerant now used is R600A, or isobutane. This refrigerant is naturally occurring, and has a smaller effect on the atmosphere if released. There have been reports of refrigerators exploding if the refrigerant leaks gas in the presence of a spark. Disposal of discarded refrigerators is regulated, often mandating the removal of doors. Children playing hide-and-seek have been asphyxiated while hiding inside discarded refrigerators, particularly older models with latching doors. Since August 2, 1956, under U.S. federal law, refrigerator doors are no longer permitted to lock from the inside. More modern units use a magnetic door gasket that holds the door sealed but can be pushed open from the inside. This gasket was invented by Herman C.L. Sr.
Types of domestic refrigerators.
Domestic refrigerators and freezers for food storage are made in a range of sizes. Among the smallest is a 4L Peltier refrigerator advertised as being able to hold 6 cans of beer. A large domestic refrigerator stands as tall as a person and may be about 1 m wide with a capacity of 600 L. Some models for small households fit under kitchen work surfaces, usually about 86 centimeters high. Refrigerators may be combined with freezers either stacked with refrigerator or freezer above, below, or side by side. A refrigerator without a frozen food storage compartment may have a small section just to make ice cubes. Freezers may have drawers to store food in, or they may have no divisions, chest freezers. Refrigerators and freezers may be freestanding, or built into a kitchen. Compressor refrigerators are by far the most common type. They make a noticeable noise. Absorption refrigerators or thermoelectric Peltier units are used where quiet running is required. Peltier coolers are used in the smallest refrigerators as they have no bulky mechanism. Compressor and Peltier refrigerators are powered by electricity. Absorption units can be designed to get power from any heat source. A noticeable difference between the two types is the absence of refrigerant with Peltier coolers. These use a different method of cooling. But Peltier coolers use more electricity because they are thermodynamically inefficient. Oil, gas, natural gas or propane, and dual-power gas electricity units are also available, typically found in RVs. Solar refrigerators and thermal mass refrigerators are designed to reduce electrical consumption. Solar refrigerators have the added advantage that they do not use refrigerants that are harmful to the environment or flammable. Typical solar designs are absorption refrigerators that use ammonia as the working gas, and employ large mirrors to concentrate sufficient sunlight to reach the temperature required to free gaseous ammonia from the solvent. Most thermal mass refrigerators are designed to use electricity intermittently. As these units are heavily insulated, cooling load is limited primarily to heat introduced by new items to be refrigerated, and ambient air transfer when the unit is open. Very little power is therefore required if opened infrequently. Refrigeration units for commercial and industrial applications can be made in various size, shape or style to fit customer needs. Other specialized cooling mechanisms may be used for cooling, but have not been applied to domestic refrigerators. Magnetic refrigerators are refrigerators that work on the magnetocaloric effect. The cooling effect is triggered by placing a metal alloy in a magnetic field. Acoustic refrigerators are refrigerators that use resonant linear reciprocating motors alternators to generate a sound that is converted to heat and cold using compressed helium gas. The heat is discarded and the cold is routed to the refrigerator.
Energy efficiency.
In the past, refrigerators consumed more energy than any other home appliance, but in the last 20 years progress has been made to design, manufacture, and encourage the sale of refrigerators with improved energy efficiency. In the early 1990s a competition was held among the major manufacturers to encourage energy efficiency. Current U.S. models that are Energy Star qualified use 50% less energy than the average models made in 1974. The most energy efficient unit made in the U.S. consumes about half a kilowatt-hour per day, 20 W. But even ordinary units are quite efficient. Some smaller units use less than 0.2 kilowatt-hours per day, 8 W. Larger units, especially those with large freezers and ice makers, may use as much as 4 kilowatts by hour per day, 170 W. The European Union uses a letter-based mandatory energy efficiency rating label instead of the Energy Star. Thus EU refrigerators at the point of sale are labeled according to how energy efficient they are. For U.S. refrigerators, the Consortium on Energy Efficiency, CEE, further differentiates between Energy Star qualified refrigerators. Tier 1 refrigerators are those that are 20% to 24.9% more efficient than the federal minimum standard set by the National Appliance Energy Conservation Act, NAECA. Tier 2 are those that are 25% to 29.9% more efficient. Tier 3 is the highest qualification, for those refrigerators that are at least 30% more efficient than federal standards. About 82% of the Energy Star qualified refrigerators are Tier 1, with 13% qualifying as Tier 2, and just 5% at Tier 3. Besides the standard style of compressor refrigeration used in normal household refrigerators and freezers, there are technologies such as absorption refrigeration and magnetic refrigeration. Although these designs generally use a much larger amount of energy compared to compressor refrigeration, other qualities such as silent operation or the ability to use gas can favor these refrigeration units in small enclosures, a mobile environment or in environments where unit failure would lead to devastating consequences. Many refrigerators made in the 1930s and 1940s were far more efficient than most that were made later. This is partly attributable to the addition of new features, such as auto-defrost, that reduced efficiency. Additionally, after World War II, refrigerator style became more important than efficiency. This was especially true in the 1970s, when side-by-side models with ice dispensers and water chillers became popular. However, the reduction in efficiency also arose partly from reduction in the amount of insulation to cut costs. Because of the introduction of new energy efficiency standards, refrigerators made today are much more efficient than those made in the 1930s. They consume the same amount of energy while being 3 times as large. The efficiency of older refrigerators can be improved by defrosting, if the unit is manual defrost, and cleaning them regularly, replacing old and worn door seals with new ones, adjusting the thermostat to accommodate the actual contents. A refrigerator needn't be colder than 4 degc, 39 degf, to store drinks and non-perishable items, and also replacing insulation, where applicable. Some sites recommend you clean condenser coils every month or so on units with coils on the rear. It has been proved that this does very little for improving efficiency. However, the unit should be able to breathe with adequate spaces around the front, back, sides and above the unit. If the refrigerator uses a fan to keep the condenser cool, then this must be cleaned, at the very least, yearly. Frost-free refrigerators or freezers use electric fans to cool the appropriate compartment. This could be called a fan-forced refrigerator, whereas manual defrost units rely on colder air lying at the bottom, versus the warm air at the top to achieve adequate cooling. The air is drawn in through an inlet duct and passed through the evaporator where it is cooled. The air is then circulated throughout the cabinet via a series of ducts and vents. Because the air passing the evaporator is supposedly warm and moist, frost begins to form on the evaporator, especially on a freezer's evaporator. In cheaper and/or older models, a defrost cycle is controlled via a mechanical timer. This timer is set to shut off the compressor and fan and energize a heating element located near or around the evaporator for about 15 to 30 minutes at every 6 to 12 hours. This melts any frost or ice buildup and allows the refrigerator to work normally once more. It is believed that frost-free units have a lower tolerance for frost, due to their air conditioner-like evaporator coils. Therefore, if a door is left open accidentally, especially the freezer, the defrost system may not remove all frost. In this case, the freezer, or refrigerator, must be defrosted. If the defrosting system melts all the ice before the timed defrosting period ends, then a small device, called a defrost limiter, acts like a thermostat and shuts off the heating element to prevent too large a temperature fluctuation. It also prevents hot blasts of air when the system starts again, should it finish defrosting early. On some early frost-free models, the defrost limiter also sends a signal to the defrost timer to start the compressor and fan as soon as it shuts off the heating element before the timed defrost cycle ends. When the defrost cycle is completed, the compressor and fan are allowed to cycle back on. Frost-free refrigerators, and some early frost-free refrigerator freezers that used a cold plate in their refrigerator section instead of airflow from the freezer section generally don't shut off their refrigerator fans during defrosting. This allows consumers to leave food in the main refrigerator compartment uncovered, and also helps keep vegetables moist. This method also helps reduce energy consumption, because the refrigerator is above freeze point and can pass the warmer than freezing air through the evaporator or cold plate to aid the defrosting cycle. Regarding total life cycle costs, many governments offer incentives to encourage recycling of old refrigerators. One example is the Phoenix Refrigerator Program launched in Australia. This government incentive picked up old refrigerators, paying their owners for donating the refrigerator. The refrigerator was then refurbished, with new door seals, a thorough cleaning and the removal of items, such as the cover that is strapped to the back of many older units. The resulting refrigerators, now over 10% more efficient, were then distributed to low-income families.
Effect on lifestyle.
The refrigerator allows the modern family to keep food fresh for longer than before. This, along with the modern supermarket, allows most families, without a sizable garden in which to grow vegetables and raise animals, to enjoy a vastly more varied diet and improved health resulting from improved nutrition. On the other hand, refrigerators and freezers can also be stocked with processed, quick-cook foods that are less healthy. Refrigeration in transit makes it possible to enjoy foodstuffs from distant places. Dairy products, meats, fish, poultry and vegetables can be kept refrigerated in the same space within the kitchen, although raw meat should be kept separate from other foodstuffs for reasons of hygiene. Freezers allow people to buy food in bulk and eat it at leisure, and bulk purchases save money. Ice cream, a popular commodity of the 20th century, could previously only be obtained by traveling to where the product was made and eating it on the spot. Now it is a common food item. Ice on demand not only adds to the enjoyment of cold drinks, but is useful for first aid, and for cold packs that can be kept frozen for picnics or in case of emergency.
Temperature zones and ratings.
Some refrigerators are now divided into 4 zones to store different types of food. 18 DEGC, 0 DEGF, freezer, 0 DEGC, 32 DEGF, meat zone, 5 DEGC, 41 DEGF, cooling zone, 10 DEGC, 50 DEGF, crisper. The capacity of a refrigerator is measured in either liters or cubic feet. Typically the volume of a combined refrigerator freezer is split to 100 liters, 3.53 cubic feet, for the freezer and 140 liters, 4.94 cubic feet, for the refrigerator, although these values are highly variable. Temperature settings for refrigerator and freezer compartments are often given arbitrary numbers by manufacturers, for example, 1 through 9, warmest to coldest, but generally 3 to 5 DEGC, 37 to 41 DEGF, is ideal for the refrigerator compartment and 18 DEGC, 0 DEGF, for the freezer. Some refrigerators must be within certain external temperature parameters to run properly. This can be an issue when placing units in an unfinished area, such as a garage. European freezers, and refrigerators with a freezer compartment, have a 4-star rating system to grade freezers. Min temperature equals 6 DEGC, 21 DEGF. Maximum storage time for pre-frozen food is 1 week, min temperature equals 12 DEGC, 10 DEGF. Maximum storage time for pre-frozen food is 1 month, min temperature equals 18 DEGC, 0 DEGF. Maximum storage time for pre-frozen food is between 3 and 12 months depending on type, meat, vegetables, fish, etc. Min temperature equals 18 DEGC, 0 DEGF. Maximum storage time for pre-frozen or frozen from fresh food is between 3 and 12 months. Although both the 3 and 4-star ratings specify the same storage times and same minimum temperature of 18 DEGC, 0 DEGF, only a 4-star freezer is intended for freezing fresh food, and may include a fast freeze function, runs the compressor continually, down to as low as 26 DEGC. 15 DEGF to facilitate this. 3, or fewer, stars are used for frozen food compartments that are only suitable for storing frozen food. Introducing fresh food into such a compartment is likely to result in unacceptable temperature rises. This difference in categorization is shown in the design of the 4-star logo, where the standard 3 stars are displayed in a box using positive colors, denoting the same normal operation as a 3-star freezer, and the 4th star showing the additional fresh food fast freeze function is prefixed to the box in negative colors or with other distinct formatting. Most European refrigerators include a moist-cold refrigerator section, which does require automatic defrosting at irregular intervals, and a rarely frost-free freezer section.
Recycling.
In Mexico, the federal government has created the program Cambia tu viejo por uno nuevo, change your old refrigerator for a new one. The old refrigerators are recycled to recover their components, refrigerant gas, copper, glass, iron, etc.
Refrigerator.
A refrigerator is a common household appliance that consists of a thermally insulated compartment and a heat pump that transfers heat from the inside of the fridge to its external environment so that the inside of the fridge is cooled to a temperature below the ambient temperature of the room. Refrigeration is an essential food storage technique in developed countries. Lower temperatures in a confined volume lowers the reproduction rate of bacteria, so the refrigerator reduces the rate of spoilage. A refrigerator maintains a temperature a few degrees above the freezing point of water. Optimum temperature range for perishable food storage is 3 to 5 DEGC, 37 to 41 DEGF. A similar device that maintains a temperature below the freezing point of water is called a freezer. The refrigerator replaced the icebox, which was a common household appliance for almost a century and a half prior. For this reason, a refrigerator is sometimes referred to as an icebox in American usage.
History. Refrigeration technology.
Before the invention of the refrigerator, ice houses were used to provide 1860. Carl von Linde, an engineering professor at the Technological University Munich in Germany, patented an improved method of liquefying gases in 1876. His new process made possible the use of gases such as ammonia, sulfur dioxide, SO2, and methyl chloride, CH3Cl, as refrigerants, and they were widely used for that purpose until the late 1920s.
Domestic refrigerator.
In 1913, refrigerators for home and domestic use were invented by Frederick W. Wolfe of Fort Wayne, Indiana, with models consisting of a unit that was mounted on top of an ice box. In 1914, engineer Nathaniel B. Wales of Detroit, Michigan, introduced an idea for a practical electric refrigeration unit, which later became the basis for the Kelvinator. A self-contained refrigerator, with a compressor on the bottom of the cabinet, was invented by Alfred Mellows in 1916. Mellows produced this refrigerator commercially but was bought out by William C. Durant in 1918, who started the Frigidaire Company to mass-produce refrigerators. In 1918, Kelvinator Company introduced the first working vapor compression refrigeration system in the world. It was a closed-cycle device that could operate continuously. A similar attempt was made in 1842, by American physician, John Gorrie, who built a working prototype, but it was a commercial failure. American engineer Alexander Twining took out a British patent in 1850 for a vapor compression system that used ether. The first practical vapor compression refrigeration system was built by James Harrison, a British journalist who had emigrated to Australia. His 1856 patent was for a vapor compression system using ether, alcohol or ammonia. He built a mechanical ice-making machine in 1851 on the banks of the Barwon River at Rocky Point in Geelong, Victoria, and his first commercial ice-making machine followed in 1854. Harrison also introduced commercial vapor compression refrigeration to breweries and meat packing houses, and by 1861, a dozen of his systems were in operation. The first gas absorption refrigeration system using gaseous ammonia dissolved in water, referred to as aqua ammonia, was developed by Ferdinand Carr of France in 1859 and patented as the first refrigerator with any type of automatic control. The absorption refrigerator was invented by Båtsar von Platen and Carl Munters from Sweden in 1922, while they were still students at the Royal Institute of Technology in Stockholm. It became a worldwide success and was commercialized by Electrolux. Other pioneers included Charles Tellier, David Boyle, and Raoul Pictet. Carl von Linde was the first to patent and make a practical and compact refrigerator. These home units usually required the installation of the mechanical parts, motor and compressor, in the basement or an adjacent room, while the cold box was located in the kitchen. There was a 1922 model that consisted of a wooden cold box, water-cooled compressor, an ice cube tray and a 9 cubic foot, 0.25 m3, compartment, and cost $714. A 1922 Model T Ford cost about $450. By 1923, Kelvinator held 80% of the market for electric refrigerators. Also in 1923, Frigidaire introduced the first self-contained unit. About this same time, porcelain covered mud cool storage for most of the year. Placed near freshwater lakes or packed with snow and ice during the winter, they were once very common. Natural means are still used to cool foods today. On mountainsides, runoff from melting snow is a convenient way to cool drinks, and during the winter one can keep milk fresh much longer just by keeping it outdoors. The word refrigeratory was used as early at least as the 17th century. The history of artificial refrigeration began when Scottish professor William Cullen designed a small refrigerating machine in 1755. Cullen used a pump to create a partial vacuum over a container of diethyl ether, which then boiled, absorbing heat from the surrounding air. The experiment even created a small amount of ice, but had no practical application at that time. In 1805, American inventor Oliver Evans described a closed vapor compression refrigeration cycle for the production of ice by ether under vacuum. In 1820, the British scientist Michael Faraday liquefied ammonia and other gases by using high pressures and low temperatures, and in 1834, an American expatriate to Great Britain, Jacob Perkins,